Hey everybody, this is Larry. This is me going over Q4 of the bi-weekly contest 140. Find the occurrences of the first almost equal substring. I think I said it right. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So it turns out that there is another way of doing it versus the way I am doing it. I'm going to go over the way that I'm doing it, and then I'm going to live solve, at least on video, the other way that I understand. And you can watch that. I'll go over it as we go over it. I think the other way is actually easier. So the way that I'm explaining it and the way that I solved it during the contest is a little bit hard. But yeah, but basically the way that I thought about it is actually the code is a little bit messy and can definitely get a little bit yucky, and we can definitely make a lot of mistakes. And I made 3 wrong answers. So we saw some typos and some premature optimization, some optimizations, but I kind of messed up due to the optimization. So, so maybe Rabin-Karp wasn't the best way, but nonetheless, right? So, okay, so what is Rabin-Karp? I'm not going to go over it in super detail, but I'm going to give you a high-level overview of what I needed for this contest, for this problem. And just to also give you a sense, you definitely need to actually understand Rabin-Karp, so definitely pre-study it or whatever for this, right? So what is Rabin-Karp? In very quick detail is that so you have some character, right, or some string, sorry, right, and then the idea here is that we just want to convert it to and this is the pattern. So this is the pattern. We just want to convert it to a number. And how is that number? Well, the number is just a base something number. The base should be bigger than the size of the alphabet, just to keep it easy. So let's say this is a base 30 number. So we choose our base to be 30. So that means that here, if you go from least significant digits, then A is going to be, you go to A, which is 1 times 30 plus, oops, nasty handwriting, plus G, what is G? A, B, C, D, E, F, G, 7? If I'm off by 1, it's fine, right? All right, I'm going to write this the other way so that's a little bit easier. So it's 1 times, or maybe I could have done it vertically, right? So 1 times 30, and A is equal to this. G is equal to the 7 times 30. This is to the power of 0, right? D is equal to 4 times 30 to second. C is equal to 3 times 30. So this is basically like a and dot dot dot. I'm not gonna write it out. It's fine. This is basically like how a number is in our system, in our decimal system. You have tens here instead, and it goes from 0 to 10, right? Or 0 to 9. Sorry. Excuse me. But yeah, the idea here is that we're just trying to convert it to a number. And here we, 1 digit at a time, for the pattern, we just kind of do this thing, right? And it turns out you can do this with like Horner's rule, which is also shift and add. We'll minimize it, right? So you actually do it this way, right? So if you do it that way, it actually ends up looking like this instead, which is that you have 1 times 30. It's 1 shift, just times 30, plus B, so this is A. B is going to be 2, right, times 30 plus A, and then you dot 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 out the parens. And of course this is and this is how you kind of, if you have another way to think about it is that if you have just like a regular decimal number, like 1, 2, 4, 5, I don't know, I'm just writing numbers, you can think about this as 1 times 10 plus 2 times 10 dot dot dot, right? So you got to construct this one at a time from left to right. So this is basically Rabin-Karp in a thing, right? And the way that we solve matching problems, needle and haystack problems, is that, okay, now you have this number, right? It gives us some number. I'm just going H for hash. And the idea here, of course, is that this number gets really big because if the pattern has, I don't know, 1,000 digits, then here you need to do 30 to 1,000, right? Which is way too many. It's just way too big. So then now you want to have something to mod the answer by some prime. It doesn't even have to be a prime, though. Of course, you reduce odds of false positives in theory if you don't have an adversary. But that's basically the answer, right? So after doing this function, you mod it by some p, and you get some you get some hash, right? So you get some hash for the pattern. Okay. So now, how you do haystack is that, okay, let's say now you have another string, right? I don't know. So this is the other one, the word 1 or whatever. So then now this is the pattern is length 7. So in a sliding window kind of way, if you just look at this window, for example, this will give you some hash. So this gives you a pattern hash. I'm going to call ph for pattern hash. Nasty handwriting. But then here, now we have another h, right? And then we just compare. If it was exactly the same, we just compare to see if they're the same, right? I'm going to change the color real quick. We're going to see if... I thought I changed the color. What is going on? I don't know why it's not letting me change colors, but okay, well, we just have to do. Yeah, so if pH is equal to h, then we're done, right? The idea behind the sliding window is that now we slide one to the right if it's not, right? So then now this, I wish I had, sorry friends, I wish I could change colors, but it's not changing for some reason. But yeah, then now you have here, right? And it turns out that, let's call this h0 and this is h1, that, you know, if you're shifting, that means that shifting that way is the same as multiplying it by 30, right? Plus the letter a, which in this case is going to be a 1, right? And then we want to also subtract this a because now it's outside the hash. So then now we subtract it by a, which is 1, times 32 p, right? And of course we mod this afterwards, right? And this is equal to h1 in a sliding window kind of way, right? So okay, this is standard Rabin-Karp so far, no changes. And I know that I'm going fast. If you want a slower version of this, watch a Rabin-Karp tutorial, just because, you know, trying to keep this video a little bit short, but yeah, okay, just want to make sure that I have the right thing on screen. So that's basically the idea. Well, okay, so then now we have all these hashes, you know, we have h, why I can't change colors. This is so weird. Okay. Well, now we have h0, h1, h2, h3, dot, right? And the idea here is that if any of these, or, well, we want the first one, so we just want to match it with pH, right? Because basically, using the same algorithm, this should give us the same hash for the same length for the same one. So then now we just... So now we just check whether pH is equal to the first one, the second one, the third one, and so forth, and return early, right? And then now, the idea here, so this is, again, standard Rabin-Karp. So how do we solve this one? Where it is the same but almost the same, right? You could change one character. Okay, well, mathematically, then now what are we saying here, right? And I thought about this during the contest. This is not like if you watch the live portion, you see me work this out. It's not it's not a um, um, yeah, I mean, so yeah, yeah, it's not something that I came up with. It's something that I came up with during the contest. It's not something that there's. I mean, there's probably there is probably literature on this, but I didn't know it anyway. I came up with this during the contest, and so this is the way that I think about it, right? So now we want to change one character. The naive thing to do, right? One way that you can do it, and this is the natural way, is that okay? Well, let's say you have this thing, right? There are a couple of ways to think about it. Let's say we still have the pattern, so then now we have pH, right? Well, the thing is that then we can maybe just subtract one character, right? And they're p characters. So, and what I mean by that is that you could maybe instead of, the entire string, you could say we have one space and then do the math on this. We try another one. Maybe I wrote it wrong, but you get a hash for this, you get a hash for this, and then dot dot dot, and then you do the same for the source string, the haystack, and do match, right? But of course, this is going to be too much because this has p's, because there are p different substrings, right? And there are p different ways that you can remove one character. And because each string is length p, this is going to create p squared time, right? I guess this part is actually not that bad. I lied. Sorry. But my mouse is being weird. Sorry. But yeah, actually there are p different strings. So this is actually feasible if you're able to do it. However, the harder problem for this part is that you can pre-process p in this way, but the string is a little bit different, right? So if we had our sliding window e string, right, whatever, like the very long string, then here for this suffix we have to try removing one character, removing the second character, removing the third character, and so forth. And now, instead of this being O of 1 to calculate from shifting, say, right? Instead of this being O of 1, this is now O of P, right? Because you have to calculate it once for each of the P possible substrings. And that's too expensive, of course, right? Because now we have n strings, p of each, so this is now O of n times O of p, which is O of p times n, because I don't want to say np, that's just confusing, right? Which is too slow for this one. So how did I do it? The way that I end up doing is by looking at the formulas, right? So if I had some, let's write it out a little bit real quick, right? So maybe we have 1 times 30 to the 6th in this case, plus 2 times 30 to the 5th, minus plus 1 times 30 to the 4th, plus 3 times 30 to the 3rd, dot dot dot, right? I'm just gonna write that out because I ran out of space. But yeah, yeah, right? So this is the pattern, right? This is pH. This is the hash, and you could hash it. Yeah. Sorry, my setup is very weird today. It's just like giving me all sorts of random issues. So this is the hash, right? And then now, if we have a window, let's say we have a, I don't know, W for window. Oh, what the? W for window, WH for window hash. We also have another thing of like, so if this is exactly the same, then it would look something like this, right? And of course there is some mod in it, mod p, right? right? So if they look exactly the same, then we're good. But what if we miss by one character? What does that mean? Well, if they change by one character, for example, in the first few characters, then let's say if this is a 3, this means that this is a C, right? If this is a 3, then if you subtract them, you get a delta of this mod n, right? Because everything else matches, so everything cancels out. So this is the idea. This is the number that you get. Maybe mod p, right? So that's basically the idea behind this problem. Is that okay? Well, look, that I solved anyway. Is that okay? Well, that means that we only have 26, or the amount you do it, 26 or 52 times for each character, right? Because here, what can this number be? This number could be, I guess, negative 26 to 26, right? And what can this number be? It is 30 to from 0 to p minus 1, right? So that's basically the idea. And here, that means that we only have 52 times p possibilities. And that's really the idea that that's really the idea that I have for this problem. I'm trying to find the window so I can scroll down. I think this is it, right? Okay. Yeah, so that's basically my idea behind this problem and how I solved it. Again, I have a lot of silly mistakes, but yeah, let me actually. I optimized mine a little bit, so that's why I want to. I think this one is good. But I just want to, yeah. So okay, so this is basically what I have. Yeah, this is hashing the pattern, finding the hash for the pattern, right? For the thing, and then here is all possible 26 times. And you can actually be a little bit specific, but it's fine. Plus p possibilities. You know, we just basically these are the possible answers, and where it comes up is this later is that okay, this is standard window, right? So this is standard starting window Rabin-Karp. I know that I'm a little bit fast in this part because this is standard Rabin-Karp implementation, so I'm not going over it. But yeah, so this is to get the window, and now at this point, p is the hash for, I don't know why we have p instead of h, but anyway, p is the hash for the current window. And then we have two cases, which means that if it's Leetcode, then we can return. Otherwise, if this is in the lookup, which is what we said before with the, you know, 1 digit off, then we can return this thing. Yeah, that's pretty much it. What is the complexity here, right? This is going to be O of p. This is going to be O of p times 26, which is O of p times a, where a is the size of the alphabet. And in this case, everything, and this is just n, because this is shift and add. This is a number comparison and a lookup, which is O of 1, right? So this is O of p times a plus n time. And for space, this is O of p times a, and that's pretty much it. A being a is alpha for 26 for the size of the alphabet, and that's pretty much all I have for the way that I solved this one. You could watch me solve it live afterwards, but for now, I do want to upsolve this because I did not know, I didn't know this during the contest. But apparently, there is a much simpler way, which is how more people got, or at least. When I was doing this, more people got this one than Q3, the greedy. But yeah, but this requires the use of a Z function. And for this one, I am not going to go over Z function, honestly. You just have to kind of look it up. The only thing that I know about it, I don't really know it that well anyway to explain it. But the way that I think about it, the way that I would think about it, and the way that I do think about it, is that for a given string, what do you want to do? For a given string, the z function is where z sub I, z sub I is equal to the longest common longest prefix, common prefix between s sub I and s sub 0, right? So the length of the equal to the length of the, and that's basically the idea, right? So in many cases you can, and usually do something like right? And you can print it out just to kind of illustrate why we need to do this. For example, I think I had it the other way. Whoops. Yeah. Yeah, the idea here is, as an example, is that you have something like this, right? By taking advantage of it, I think it's the other way actually, Larry. It means that the first answer is going to be, okay, so given this, okay, well, we actually, the first thing, the pattern doesn't really matter, so we skip it for a second. But then now, A, it means that, okay, well here, if this matches the prefix, which is this, how long does it go, right? And we have a hashtag as a delimiter because then nothing else can match the hashtag, so that it always ends at most 6. So this is 0, this is going to be 3 because BCD is equal to BCD, and then this is going to be 0, 0, ... right? There would only one B. So that's basically the core idea behind this problem, is that, okay, well, and I'm live solving this, so I'm a little bit not as smooth as the explanation part. So okay, so we have something like this, and we're able to get that. So what does this buy us? Well, now that we know that the prefix is 3, now we just have to check if the rest is equal, right? And that's really the idea, because then now the rest is going to always be a suffix, and because it's the suffix, we can just do the same function in reverse, right? So then maybe we have this, because then now this is saying in reverse, you have GFFDCB hashtag GFEDCBA, right? And then now this is in the same way. This just allows you to kind of be like, okay, well, this matches 2, right? This matches 0, ... And the thing is that, okay, this matches 2 here, and this matches 3 here, and then now it's just about combining both of them in a way that allows you to skip one character, right? Because what does skipping one character mean? It means that from here, we can skip the first character that we, if this gives you 3, that means that we match in a greedy way. The 3, skip one character, and then see if we can match the last 2. And the last 2, which always have to be complete suffix, will be in the reverse one. So then now it just becomes the math here, right? We just have to be careful. Yeah, so then can I be the answer? Can I be the beginning of an answer, right? So it is an answer if, okay, so then offset is maybe is going to be C for, I didn't, wait. So Z is equal to this, right? And then now we have this for reverse Z. And then now the Z function of I plus p is equal to p. Keeping in mind that you know, we have to skip the first p characters, n plus 1. So yeah, so p plus 1, right? So this is the offset from the left side, right? Yeah. And then how do we calculate the right offset? Okay, well, the left offset is this, so that means that the next character after that is going to be wrong. So that means that yeah, we're working it out. I mean, I'm working out now, so I'm not even I'm talking to myself a little bit. So plus I plus offset is different. So then now I plus left plus offset plus the rest, right? But you also know the length of this if it matches, which is I plus p. And I plus p is going to be this index, right? You have to be very careful with indexes. So I plus p is going to be this index, and then you convert it back to here, right? In the RZ of so you have n okay, so you have p plus 1 plus to subtract this part, right? And then now it is the reverse, which is plus n, which is the number of strings, minus, I want to say I plus offset, left offset, to get to, okay, well, let me rewrite. So to get from here to here, it's going to be I plus left offset. So then to reverse it, it's just n minus this, and then you plus n p plus 1 as the prefix. So this is the right offset. And basically, if left offset plus right offset plus 1 is greater than or equal to p, then we can return I, right? Because this means that we match more than enough on the left side and the right side, and then you plus 1 for the freebie, and we can return I. I think this is maybe right, hopefully. Apparently this is our bounds. But the idea is what I'm trying to go. Okay, so if this is 0, let's just also just chop off the first p plus 1 too, so then I don't have to deal with this part, right? Yeah, let's see. Oh, yeah, then now it becomes a little bit clearer because I have to, this has to be plus 1 for the, or n minus 1 more specifically. But okay, so this isn't quite right, but we have an idea. I mean, it's right for this one, which is yay. But yeah, but I mean, this is the idea. We'll see. So 0. Okay, so this has 3. But the G of, am I doing this wrong? Two, right? So this, oh, the I plus, oh no, this isn't I plus left offset, right? Because this is, should be I plus P. there should be I plus P is the last character here. Now I plus offset is this one, but I plus P is this one. So I think I messed up there. Okay. But it's still wrong, but I think we're a little bit better. Maybe we don't need the +1. I think that's the maybe the issue. Yeah. And then yeah, now this looks good. As long as you get the indexes, and hopefully what I showed you, you know, because I was just getting the wrong indexes in a way, but hopefully, yeah, showing you that how to get the right index, because, okay. Well, apparently, you know, what's going to always make a silly mistake, but yeah, the thing was that I had left offset, but that was just counting the wrong one, right? Because I plus left offset would be this one, for example, is the first character that it doesn't. But it should be I plus P to get the end of that string, which is what this matches, right? So this is not even left offset, it's left match, right match, right? So maybe this is a little bit cleaner in terms of thinking about it, because I plus left offset, I plus P is the last character. I think so anyway. But apparently I'm doing a little bit thingy wrong. Why is that? I mean, I also printed with a print statement, so that would also probably be not Gucci, but okay. So why do I think this is a 3? Let's print it out. Let's not have this, but okay. So 0, 1, 2, 3. Oh, because this goes out of bounds, right? Okay, I'm just being dumb because this goes out of bounds, and this gives a negative number which matches random stuff, right? So okay, so yeah, if I plus P is greater than you go to N, we break, right? We can probably just return -1 as well. Why does that break the other stuff? Because this is the prefix starting at thing, right? I mean, this works for this one, but why does this? Did I get lucky with the indexing? Is that the thing? 1. Oh, I see. Because I plus P is N, this would be 0. So actually it should be +1. Okay. Yeah, I guess that makes sense actually. Yeah, well, still. I plus P plus 1. Huh. Oh, it's minus this. So if it's +1, now it would get a bigger number, right? So then this would be -1. So if I plus P minus 1, am I just like being dumb? I mean, I am being dumb, but why does this work? Oh, I get, okay, I see. Because it's greater than you go to N. It doesn't actually, I was looking at this index to think about it going out of bounds, but that doesn't even matter. Because basically what I want is this. I think that's actually what I want. Because if I plus P is equal to N, this will be just 0. Okay, I'm just being dumb. Okay. So maybe I was always going to make a silly mistake. But can I still print stuff? I do still print stuff, so this will time out. Whoops. Apparently I'm going to make a lot of silly mistakes. But okay, let's give it even on live solving. But yeah, but that's pretty much it, really, right? The use of Z functions, I'm just being a little bit sloppy. Like I said, I paste this in. I have it pre-written. I think maybe even ChatGPT wrote the first one. You write the set function, the reverse set function, the CDN. You want to see how much the left match and how much the right match. If they match enough and one character, then yeah, then you can return I. That's pretty much it, really. Let me know what you think about this one. Yeah, I mean, I don't know. I didn't do it this way. This way seems a bit easier. But yeah, thanks for watching, and you can watch me solve it live. Oh, complexing. So the thing about Z function is that this is linear n plus p. This is n plus p, right? Just reversed, and this is O of n. So yeah, so everything is n plus p linear time. In terms of space, this is O of n plus p as well, but you know we only chop it off. So linear time, linear space, and that's what I have for this one. Thanks for watching, and yeah, you can watch me solve it live during the contest next. Say it is YOLO. Probably wrong though. This okay. Well, actually, I was very doubtful, honestly. People did get it though. How many people got 16? So we're doing pretty okay. Whew, now we just have to get Q4. That was kind of hard. Okay. People got it relatively quickly. So, okay. SN pattern. Same as okay. So it's like a shift and but could be a huge character. How do I do an almost string match without keeping track of like n of them every time? Because that's n squared. Why is there a follow-up on a contest farm? They could add that in later. Not fun. But okay, let's see. How do I do it? Okay, yeah, no, that's it. Maybe that is a hint though. I feel like the way I'm doing it is kind of wild. Oh well. I have to subtract. Okay, right. -3, that is actually funny. Should be. Okay, so at least that matches. I'm getting it though. I'm not, but P minus PH should be something. It's a multiple of base. I don't know if this quite works. Oh, I mean, this just. Yeah, that's not right. I was hoping this would be right, but no, this isn't right. This is just if it's so okay. So you have this number. It has to be a power of. Okay. 26 times n. Okay, fine. 26 times p. I don't know if that's fast enough, honestly. One, two. It's very awkward always. That's 1 to 26. No, but it's exact. It's off by 1. So then, if it's off by 1, it is not going to be from this. It's going to be from this. Right? No. What am I doing? Why is 900 is 900 sounds good. That's what we want. Is this right though? Oh no. Yeah, YOLO. But we move the printout first, Larry. Alright, fine. Ooh. So this is 1. Am I off by 1? I am off by 1. Because it takes the entire. And funny thing is because I did the optimization. Oh man, what am I doing? Wow. What? Why am I? Oh, the base is different, Larry. You idiot! You can't do it this way. My optimization. I try to be smart. Leetcode messing with me. If I had my original solution, it would have been. It might have timed out, but it should be right. Okay. Apparently, I just have a lot of wrong answers now. This is today, which is very sad. A lot of people did not get wrong answers. Maybe there's an easier way to do it, or maybe it's just cheerable. But that's done 2 mistakes though. I've That's not true. We share the same thing. That is a legit optimization. Why was it not working? Why doesn't this work? Actually, am I just forgetting to add stuff? Oh, because I'm starting from 1 and not the okay, you're just being dumb, Larry. Okay, at least now you're consistent again. But so many wrong answers. Expected 7. And I got 2 wrong answers from 1 silly thing, but okay, fine. I thought this looked a little bit odd, but from 0 to 26, 7. So 7. Should be the answer. I guess it's just not, maybe it's too weird. I don't know. This is dumb, Larry. What are you doing? So there was a bug that I got 2 wrong answers for, but it was the wrong one. This is in it. Oh no, but that's 16. No. So this is in it. Why is it not? Oh, it has to be both. Okay, so okay. I rushed the end a little bit. YOLO submit. I don't absolutely why you would do it, but yeah, I'm just should have gotten this one, but the three wrong answers is sad, I think. Otherwise I would have been 22nd or so. Well, I mean, I don't know how often this updates, but in theory 22nd or so. Oh, 25-minute penalty, so maybe I'm not. Nope, still too slow then. Okay, yeah. uh, 15 minutes is rough. I think it should have been only 5 minutes, honestly. But I guess this should have been. I think I was just lazy. I think this should have been. You know, just 3 times 10 to the 5th. That would have been much faster. Right? And maybe I could have done this. Because I forgot. So this was the issue. This thing that I just didn't. I rushed my fix a little bit. Yeah, I should have just done it once. I was trying to be too cute with that. I guess the other way to do it would have been. I don't have this. It probably times out though, right? But then I took it away anyway, so that was just kind of silly. I think I have to do p+1, but not quite sure. Doing some silly optimizations just in case that they do some post contest, you know. But I don't think that should be good. I mean, they could challenge these cases, but so I didn't even need optimization. I mean, I think one of the wrong answers was legit, right? How does this differ so much? One of the wrong answers was legit. Because I thought absolute value would fix it. But I didn't really think it through. I mean, I should have known that this is actually true as well, but I just kind of rushed it a little bit in fixing it. I don't know if this is the intended solution though. K consecutive. I don't know how to do a K consecutive, honestly. That was not a hint for me. But yeah, I mean the 15-minute penalty kind of killed it. 2 of them were legit though. So I guess because I think one of them was I just forgot to do this case. I mean, it's legit if you care about because apparently you don't need the setup for it. But and then the second one was the absolute value. So at least 2 of them are legit. The third one is because I blame Leetcode. I just blame Leetcode about stuff. Okay. How do I do random again? I'm just gonna add a random case of in case people like to challenge me. I don't know. I think they said that they don't allow challenges like this, but it's hard to say anymore, so I don't know. Someone like this, isn't it? I'm Googling. I hope that yeah, it should be okay. I hope that Leetcode doesn't kind of somehow fail this. I mean, they still might. I don't know anymore. I don't know how to do the K consecutive one. I mean, this one was hard. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, the explanation, this contest, everything in between. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.